So what we're going to look at now is creating our own model. I'll just start with this. This is an example here. So here we're saying that we've got the lowest temperature on a day is 3 degrees Celsius at 3 a.m. and the highest temperature is 21 degrees Celsius at 3 p.m. And we're going to use a trig model to model this temperature. Now you pretty much follow the same sort of steps each time. I'd always do a quick sketch of our axes and I just work out what sort of scale do I need. Now you can see that the highest temp is going to be 21, so I'd write that in, and the lowest is going to be 3. Now what we can work out straight away is what the midpoint is. In other words, what value does the model oscillate around? So the way to do that is obviously just add the two together and divide by 2, so we get 12. So these two are going to oscillate around 12 degrees, which means that in our model we're going to have plus 12 at the end. So we're going to have this model plus 12. Okay, so that's what that'll happen. Then what we do is we start looking at our scales. Now we're using T is going to be the number of hours after midnight. So I'm just going to go through and say, well, if that's midnight there, then that'll be 3 a.m., 6 a.m., 9, there's midday. Oops, I should label these. That's midday. 3 p.m., 6 p.m., 9 p.m., and then midnight. Okay, and that's where our day ends. And now we can go and plot those 2 points they gave us. So we know that at 3 a.m. it's at the low point, 3 degrees, and at 3 p.m. it's at the highest point, 21 degrees. All right, so that's where I'd sort of start. The first thing is work out what they're oscillating around, and then I'd plot the data we've got. Now we know that these 2 points when we're given are 12 hours apart. So it's going to take 24 hours then to oscillate around through the whole model, which is useful. And we know that if we go to halfway between those two, it'll be 6 hours after 3 a.m., so at 9 a.m., it will pass through that line of oscillation. Okay, because that's midway between the lowest and the highest point. And then another 6 hours on, after our high point, it will come back down through that midpoint. So you can sort of see a rough shape of our curve now. So that's going to come like this, down to our low point, and then back up again. It's a terrible looking model, sorry. That comes down and then starts to come down like this. And that's how we sort of form our models. We plot the points we know, which were the maximum and the minimum, and then we look at those points that are halfway between them, and we can sort of get where this model is going to go through that line of oscillation. Now what we do is we think, well, what does it look like? And to me, I'm going to go, and you could go with cosine, I'm going to go with the fact that it looks a little bit like a sine graph. A sine graph typically would start there and go up. So if I decide this looks like a sine graph, so I'm going to say the temperature, which is going to be capital T. The first thing is it's going to be a sine graph, so I'll put in sine, and I know it had plus 12 at the end. Now I can work out the amplitude. So remember, the amplitude is how far it oscillates. So if you look on my graph here, it oscillates up as an extra 9 degrees. So that means the amplitude is 9. Now we know also that our sine graph has been shifted across from where it normally sits over there on the y-axis, shifted across 9 hours. So therefore we're going to have t minus 9 as our sideways shift. So the last thing to work out then is what is the frequency. Now remember, frequency times the period will give you 2 pi. Now our period here is 24. Okay, the period is 24 hours because it repeats every 24 hours. So we know that we've got 24f equals 2 pi, so we can rearrange that like so and simplify it to pi over 12. So that's our frequency, and that's what goes in front of the brackets. And that's pretty much the steps each time. And remember, it was draw the axes out, plot, work out your scale, what's the highest and lowest, put in the time from 12 a.m. onwards, plot those high and low points, work out where those midpoints were, so we know where it crosses that line of oscillation, and then decide, is it going to be a sine or a cosine graph? And I just went with sine here because it was easier just to sort of start there. I could do a cosine graph starting from this point here if I wanted, but I've decided to go with sine graph from there. So anyway, that's just one example. I might do another video on another one too, just so you can really get that reinforced